Hello everyone, welcome to a quick tutorial for SLPv2. So there's currently no wallet for SLPv2. However, the protocol is, like as the S says, it's pretty simple. So we can just use Electrum ABC, which doesn't speak anything token, but it can, we can still use some of the op return features to not quite manually, but pretty manually create some SLPv2 transactions. So I actually already did one just now. So you can see this is fresh off the press 14 minutes ago. I created a token called first SLPv2 token. Yeah, nomen est omen. And ticker is SLPv2. But that is no fun. We have to create a sister token for this, or brother token, or yeah, I don't know what gender tokens are these days. So yeah, here's the spec. It looks like a lot, but it's actually quite simple. So it really is. Where is it? It's like 3 steps: parse, color, verify, and then the different fields. Yeah, but if you want to use it, it's actually even more simple, even more simpler. You just, like here's some code that just assembles the op return. And yeah, I copied this over, so this is right in here, SLPv2, right, just normal Python code, and maybe a little over here so you guys can see all the commands. So I'll go back to Python 3. I will import SLPv2, SLPv2, yeah, there we go. And I actually already prepared a command here, so we can go through that. So this is Genesis 2, because it's the second one. It specifies all the things, right? The token ticker is going to be token 2. Token name is going to be second SLPv2 token. The URL is, this doesn't exist yet. Maybe at some point it will. Data and pub key are set to nothing. Decimals this time are 0. There's a mint amount, like an initial mint amount of 100. We can actually bump that to multiple. Then we can have 100, and we can mint a 50. And we can also create multiple mint batons. So here we could maybe even generate 3 mint batons. So yeah, so we got that. Now we have to Genesis 2. This might be a bit too long. 77. Usually it's best if you have 75, then we don't have to do any math. Anything we can remove here. Let's drop off one of the mint amounts. So now we got 71. 71 in hex is 447. So now, like, here's the protocol. We got a op reserved, which is 50. This is a currently completely unused opcode, and now I'm just hijacking it. Nobody has ever used this for anything, and yeah, now it got a meaning. Yeah, I guess. And so we got the 50, we got the length of what we just generated. We then append the string, and this is what we got. So this is our op return script. Yeah, and we just create a transaction with that. So we have to check raw hex script. Boom. Now we have to send that to ourselves. We got like 10K, rich, very rich. But we actually have to use multiple addresses, right? Because we have one output for the mint amounts and then three mint batons. So we need, can we do multiple? Copy address, question mark. Yeah, that works. So we need, this is the minimum dust amount. Actually, let's do more, then it's a little easier to spend. So let's do 50 or 60, I don't know. Doesn't really matter. So this is what we spent. We can do a little preview. View. Got op return, op reserved, as I said, and then one single push up, which pushes all the data for our Genesis. And just for a sanity check, we can actually display this in like quote unquote human readable, super human readable. It says SLPv2, SLP2. It says Genesis token is the token ticker. That's the full name. That's the URL. Then 0 for some other fields, and 1 mint amount with this amount. I think that's 100. And then 3 mint batons. That's like the very last byte right here. So we can sign it, signed, and we can broadcast it. Now let's all pray to Jesus that this worked. We can go to Firefox. Let me open a new tab so I can keep this. And here we are. There we go, 3 mint batons. That is new in SLPv2. We can't do that. We couldn't do this previously. We got a nice green color. So the color is based on the hex of this, and I think we got yeah, R is the first two, so that's 6. That's not too big. Then E is quite high, so this is a pretty green one. And then 9, so it also has a little bit of blue, so we can see a little green blue token. So yeah, and I mean that's it. Now we got the second SLPv2 token. Of course, we might want to use that, so I'm going to do a send transaction. Send transactions are like I never did one manually. I did one on RecTest, but not on mainnet. So hopefully this doesn't leave a trace of a totally failed transaction. But I mean, we got the Genesis. I think that's wonderful. That's really wonderful. So we're gonna just send. We're gonna split these. This one right here, the first output. We have to be very aware of what we're doing. So we got these 460s, and here this is like the out point. So this is the first output right here, number one, and we're gonna just spend this coin. So we're just gonna spend this, and I mean, while we're at it, we can also just like take 2 more of these. Just gonna do that, and we're just gonna split it evenly, 20, 10. Is that enough? How much was this? Just 400 bytes. Yeah, so this should be more than enough. But we also need to put the up return here, and this is gonna be a send one. Send? No, SLPv2 send. Send, we can, I don't know, help. That's good. So there's no big description here, but we can copy this just to put it here so we have it handy. So get the send, the token ID. This is also again different. So we have the transaction ID of this is going to be the token ID, of course, because that's how Genesis works. However, now this is in little endian, right? So we have to do this, which reverses the endianness, and this is the same endianness as in the rest of Bitcoin, right? Like all of Bitcoin, this is completely compatible, which was not the case with SLP. This was fixed. I don't know, it was always super annoying. Now it's probably just going to be even more annoying because like it's double. Like now we got like 2 token protocols with each their own endianness, but I don't know. We have to bite the bullet. Input amount, we only have 1 input amount. In the wait, not like we have to put a list here. So input amounts 100. That is what we have as input. So here also difference to SLP. we have to specify the input amounts. Why? Scalability. I'll do a video on that another time. Output amounts, we split this, so let's do a completely even split, 30/70. And keep in mind, this has to be exact. Like, you can't be off by 1, of course. This is SLPv1 as well. But if you are below 69, then that is also the transaction is completely invalid. It has to add up precisely. That's it. I mean, we'll leave the intentional burn for now. Yeah, so we do send 2 for token 2, I guess. So send, how does it look like? Oh, send 2, I mean. Here we go to SLPv2, send, and then it's mostly just encoded integers and hashes, so nothing too much to see there. But how long is this? Send to 50, not 50, 62. So that is 3e. So I hope everything is still fine. Yeah. So again, 50, easy to remember. This is not 50, this is 50 and in hexadecimal, but I don't know. It just is too easy to say 50. So 3e is the length of this in hex. And then send to hex. Boom. So we copy this. We put it in Electrum. Put it here, we confirm this is the first output of our of this token, which is this right here, 6CE, first output. So let's do a quick preview again. Yeah. I forgot to check this box. So thank God I didn't press. Okay, so we've got OP reserved. We got this right here. I didn't know it unchecks every transaction. So I'm gonna sign it. There's some, okay, so some are gonna be sent to this, but this is fine, I guess. Right, like, so the change address is not at the end. I don't know if I can change that, no pun intended. But anyway, it's gonna go back to a wallet anyway. So broadcast, boom, payment sent. Let's see. Should also just be able to refresh this. Now this is spent, boom, and wow, it's still valid. This is a valid transaction. So we just split these two outputs. One of them should be in our change outputs now because I don't know if we messed up. It's just that things are how they are right here. And here's the 20s. And here's the 16. That one has tokens. One of these doesn't. I don't know which one. It should be this one. This one doesn't have tokens. This one does. So this was a send. But we can also do mints. But before we do that, let's actually create a third token, like a whole big family, big beautiful family of tokens. So we do Genesis 3, then token 3 because I'm creative like that. Then the third, if I could spell SLPv2. Same thing here, everything same. This time maybe, I mean, this literally doesn't change anything. 1 mid baton, just to have it. Decimals, maybe 4. And then, of course, this needs to be more. So this is 10 of this token, 10.000. So Genesis 3, let's hope that this still fits. Genesis 3. Come on, man. Okay, it crashed. No, it didn't. 70, perfect. So yeah, we do 50. Oh, what is that in hex? If I knew, probably with 4. It's 4, right? No, 4-6. Bad math. 4-6 plus Genesis 3 hex. So we do another one of these. This time we literally can just, oh no, wait, we should probably pick something that's untaken. yeah, this is this one. We should spend this one, I think. Up return, roscro tags. Let me just double check. Oh no, not remove. 7e, 7e. Details here. Copy this. Yeah, this looks, oh man, this looks so benign. This is just a totally normal transfer. Come on, man. Yeah, nothing special here. Okay, so we can spend this, pay to, whatever actually. We just pick a new address, copy, send. This time we do max, preview. Actually, we need multiple of these, so we do another address. Right here, copy address. So we do 30, 30, I think. Change goes somewhere. Preview, does it? Yeah, it puts it in the front again. But we can add 8, 8, 8, 8. Like this, preview, perfect. So again, we got one mint amount and one mint baton. So that is now, that would be a typical SLPv1 transaction actually. So there's nothing special going on here. Let me open the new tab. Yeah, so 10 of these, 0.000, one mint baton. And that is it. So now we've been okay, well, so what is so great, right? Like why are we doing all this? Because in SLPv2 we can actually do multiple transaction types in one atomic transaction, and that is totally new. And I think we can do one mint and one send within one transaction. And let's do the mint first of this token that we just created. So mint. Let me just do the help real quick. Help, please. Tell me how does this work? SLPv2 mint. Token ID, again, little endian, very, very important. Boom. And then colon -1 to reverse it. Input baton index, we will put this at 0. So this is where is this mint baton at which index is also new in SLPv2. This again makes it more scalable and also takes literally 1 byte and just, yeah, improves things. Mint amounts, yeah, how much do we want to mint? Let's create 20. So 20, and wait, there's a 0 missing. Oop. So this would be here. I mean, this doesn't have a decimal point, so like this. And the number of batons, let's just recover 1. So this is all fine. So this is the first, so mint 1, I would say mint 3, right? So mint 3. And then we got another send. This will be send 2, because we'd have to use one token before, the one we already used, the one we already did a send, so we'll just do another send. So send 2, 1, because it's the second one, I guess. So send, we got the same things again. We can actually copy actually all my, oh 9. Copy all of that. Boom. And let's spend this 30 coin. So it's the number 1 output, and I don't know, should we just, oh wait, we actually have to put 0 here, because this is all the inputs, right? Like there's no, like this includes this mint baton, so we have to put a 0 here. Same here. The first is the 20,000. I mean, I'm one row above here. And one, so we have to actually leave a lot of room for stuff. By the way, if we messed this one up, the mint would still be valid, but the second, like it's called section, would be invalid. So we have one like token output and one baton output. And here, this again has to add up. We just put 30, so we just send it to, like this would be if a, like this could be an atomic mint, so you pay someone in a different token to do a mint. I don't know any obvious application for this, but like maybe you have some self-minting service, whatever, like this. There will be people who use this. I mean, maybe, who knows. So send mint, oopsala, mint 3. That's 51. That's pretty short. And we got to send 21, like this, 74. Okay. So let's put those in hex, and like this. So 50 again, as we all know it and love it. 33 for the mint. Then we concatenate the mint, just like this. And now again we have to put the length of the send. So this is 4a, yeah, this is 4a. 4a plus send 21 hex. So this looks really, really long, but it still fits in an output. So now we have to be extra careful what we spend, right? So we have to spend from this new token the second output, because this is the mint baton, and we just verify that real quick in a bit after I allocated everything. And then for the send we just created, which is this one. So this has 3D, and we're spending the 30. So 3D 1, where is it? 3D 1, this one right here, spend. Oh, and I messed up. Oh no, I didn't. Okay, actually, yeah, so 0.3, 0.30. So everything is totally perfect. Oh no, wait, I can't add. I can only do one at a time. But there's a list here, clearly, right? How can I fix this? Okay, so back to square one. We need to spend this output. So if I do spend, okay, that's annoying. That is, I don't like that. So I can't actually demonstrate this. This is too bad. How do I? Yeah, no, this doesn't work. Huh, sucks. So the other output would be, if we could, would be this one. Export, build avalanche proof, freeze coin, freeze address. Yeah, no, there's nothing I can do. What could I do instead? Maybe I can be sneaky and just select multiple. So we got this one, right? No, this one. So this one is the first one. This one is the second one. Spend. Aha! I have made fire. So we got the 2 coins here. Sorry for the for the figuring out things. Now it would be great if this just would like completely fail, right? So, oh, and by the way, also all the outputs, they actually have to exist, right? So we have to have 3 outputs here pretty much, right? If they don't exist, the transaction is invalid, at least the section that tries to color some coins, some addresses that don't exist. So we need 3. Boom. Ooh. Oh, yeah. Copy. Send. We don't have too much here, but we don't know it too much. Okay, 10, 10, 10. We can do preview and then allocate the rest. Oh, okay, it just barely fits. Okay, that's good. It fits very snugly. So let's just confirm so we don't do anything wrong. We got the, here, this is the 06, 08. This is this one, and the output is, it should be number 2, the mint baton, because we started with the mint. So this is indeed A2. We are spending from this send output. This one has 30, and it is A1. Here we got the 3D. 3D, this is in the second input, right? So these are ordered, and I hope this is respected. Oh, it actually isn't, so I need to add, this is weird. So I need to add more so it actually uses these. Yeah, there we go. Okay, and yeah. So I got these two. This would have failed partially. Okay, and we got the 3 outputs. Again, here this mint input and this these input amounts aren't overlapping. These one aren't overlapping either. So we should be good to go. So we sign. And let's see. This is the first time I did anything like that. Broadcast. And let's see what happened. Boom. And it worked. It worked. Wow, that's amazing. So we got 2 token IDs, 1 mint token 3, right? That's the first one. These are ordered by the way they appear in the sections. And we got the send. So here it also sends tokens. So here it sends to the no, this is a mint, right? It mints from this mint baton. It sends it over to another address, and it also creates a few tokens. And here it just sends over these tokens to here. So this is one address, and it's a new address. So this could be like someone paying someone to mint a different token type. So in my opinion, that is pretty cool. And this could be as many as you want. Asterisks. It obviously has to fit in the return data. So this is already pretty dense. Not super duper dense, right? Like got like 200 bytes, 500 bytes. So let me go 220 limit. How long is this? I mean, this is hex, so we have to divide by 2. 200. So we could fit 2 more of these, maybe maximum. Yeah, that's it. Here's the spec. It's relatively simple. There is a suggested scalable implementation based on Project Hamilton. So it is meant to be super scalable, but as you can see, it's also, I mean, like it just worked, right? Like when does ever something like this work first try? Like, and there's like sending this over Electrum ABC, there's no like pre-validation whatsoever. It just does it, and if you burn it, it just burns it. This is all only on the beta explorer, right? So we have to go to beta-explorer.b.cache. It isn't as fancy as the explorer.e.cache, but it has SLPv2. And by the way, only SLPv2. It does currently not show any SLPv1 tokens. I'm working on fixing that, but as you can imagine, supporting 2 token standards is always much harder than just supporting 1 token standard. Yeah, all right. Thank you guys so much for listening. I hope you learned something, and I'll see you in the next video, whatever that'll be. Who knows? Maybe I'll talk about elephants.